This lecture is about the derivatives of exponential functions. So remember that when the base of a function is a constant number and the power is variable, then we say that that is an exponential function. The first exponential function having base e is in front of you. You see that here's a function e power x. E is a constant number between 2 and 3. That is an irrational number, so this base is constant here, and you see that this variable is x. So the power of this function is a variable x and the base is a constant number, so that is actually an exponential function. Now what is the derivative of e power x? The derivative of e power x is the same e power x. That is a simple case, and whenever there is e power u, the power of e is actually the function of x, u. So derivative of e power u is the same e power u, but extendedly with the derivative of this power u. Here is also the derivative of x is here with the e power x, but we know that the derivative of this power x is 1, so that's why we don't write this one here. But if this is the function of u, then we will multiply the derivative of this power u. So that is the derivative of the exponential function having base e. For example, if you want to find the derivative of e power x square plus 1, we see that the power of e is the function of x, e power u. So from this formula, the derivative of e power u is the same e power u, the same e power x square plus 1, and further multiplied by the derivative of the power u. This is u, x square plus 1. Now just find the derivative of this x square, which is 2x, and derivative of 1 is 0, so that is actually 2x, and writing this 2x in front of this e power x square plus 1 is the derivative of e power x square plus 1. Secondly, if there is an exponential function but the base is not e, other than e, for example the base is 2, 3, 4, 5, etc., so in this case the formula is just like that one. We see that the base of this exponential function is a, not e, so the derivative of a power x is the same a power x along with the natural log of the base, natural log of a. If you see here, along with this e power x there is 1, and we know that log of e is 1. If you see this formula, that is log of a, natural log of a. There is natural log of e, but we know that natural log of e is 1, so that's why we don't write here log of e, and that is log of a, which is not equal to 1. Now extending this formula, if this power is not x only but the power of x, so the formula will be the same. That will be derivative of a power u is the same a power u, natural log of a multiplied by the derivative of this power u. For example, if you want to find the derivative of a power x square plus 1, so we see that the power of a is the function of x. So derivative of a power x square plus 1 is the same a power x square plus 1 along with natural log of a and derivative of the power. Remember that natural log of the base, derivative of the power, natural log of the base, derivative of the power. So that is the same natural log of the base a and derivative of the power, which is x square plus 1. Now derivative of x square is 2x and derivative of 1 is 0, so that is 2x, and writing this 2x in front of a x square plus 1 is the derivative of a power x square plus 1. So the rest of the questions and question sheets, questions on derivatives 6, half of the questions they will involve these kinds of formulas. For example, if you look at these questions, question number 15, 16, 18, 23 and 24. So question number 16 ask us about the derivative of y, where y is given to you e power 7x. So differentiate this function with respect to x. Given that y is this function, differentiate this function with respect to x. So differentiating with respect to x, y, and differentiating e power 7x with respect to x. So we know that derivative of e power u is the same e power u multiplied by the derivative of the power 7x, and we know that the derivative of 7x is 7 into 1 because 7 is constant, so that is 7 into 1, and writing this 7 in front of e power 7x is the derivative of e power 7x. Question number 18, y is given to us e power 1 by x. In the same manner, we will differentiate this function with respect to x. So differentiating y with respect to x and differentiating e power 1 by x with respect to x. That is the derivative of e power u is the same e power u into further derivative of this u, which is 1 by x. We can write this 1 by x in this fashion, e x power minus 1, and now this becomes power rule. So derivative of x power minus 1 is minus 1 x power minus 1 minus 1, and now writing this negative sign outside this function here, and that will become x power minus 2, and converting this factor in the denominator, so that will become x square. That is the derivative of y is equal to e power 1 by x. Now in question number 19, we see that y is in the form of quotient. So if you differentiate this function with respect to x, you will apply quotient rule, because in numerator there is variable, and in the denominator there is again a variable. So applying the quotient rule, that is 1 by denominator square, denominator into derivative of numerator minus vice versa. So that is quotient rule. Now if you differentiate, if you multiply, because this is difference rule, multiply this operator inside, so derivative of e power x is the same e power x, and derivative of e power minus x is the same e power minus x with the derivative of the power, and we know that the derivative of minus x is minus 1. In the same manner, derivative of this function, derivative of e power x is the same e power x, and derivative of e power minus x in this manner is just like that one. Now we just need to simplify these two factors. Multiply this negative sign here, so that will become plus, and multiply this negative sign here, that will become minus. We see that these two are same, so we can write these two as this whole square, and the same thing, these two are same, so this equal to this whole square. We know that a plus b whole square, that is the answer of this question, but we can simplify this difference. We know that a plus b whole square minus a minus b whole square is 4ab. 4ab, or if you forget this formula, just expand this by a plus b whole square and expand this by a minus b whole square, and simplifying you will get 4 into e power x into e power minus x. Now the basis of these two are same, so the powers will be added, and e power x minus x is e power 0, e power 0 is 1, 4 into 1 is 4, and 4 multiplied by 1 is 4. So that is the answer of this question. In this slide, question number 20 is here. Y is given to be sine of e power x. So whenever you differentiate this function with respect to x, first of all we will apply sine u, the formula, the derivative of sine u. The derivative of sine u is cos u into further derivative of this u, which is e power x, and we know that the derivative of e power x is the same e power x, and writing this e power x in front of cos is the derivative of this function sine of e power x. Question number 25, we are given a function y natural log of 1 minus x e power minus x. So whenever you differentiate this function, then we see that first of all we need to apply the formula for derivative, which is for log, natural log of u. Derivative of natural log of u, that is 1 by u, into further derivative of this u, 1 minus x into e power minus x. Now multiply this d dx inside. Derivative of 1 is 0, and this is derivative of x into e power minus x. Again we see that this is product rule, x into e power minus x, so applying product rule here on this factor, we will get this equation. This is from this portion. We have written this negative sign outside here, just look at that, that is a minus sign, and we have applied the product rule on these two factors to get this portion, first derivative of second plus second derivative of first. Now derivative of e power minus x is the same e power minus x with further derivative of minus x, which is minus 1, and derivative of x is 1. Again we see here that e power minus x is common in these two, so we have taken e power minus x common here, minus x left here, plus 1, so minus x plus 1, that is a negative sign. Multiply this negative sign inside, so minus into minus is plus, and minus into plus is minus. So this is the derivative of this function. From question number 27 to 30, it says that find f prime x by formula. Derivative of a power u is a power u natural log of a into further derivative of the power u, and then by using the logarithmic differentiation. We start from question number 27. Question number 27 is y is equal to 2 power x. We may say that is f of x. So f prime means derivative of the function. So taking the derivative of this function with respect to x, that is derivative of y, and that is derivative of 2 power x, that is a power x. So derivative of a power x is the same a power x into natural log of the base, which is 2. So that is the derivative of 2 power x by using this formula. Now we are using here logarithmic differentiation. What does it mean? It means that first of all we need to take log of this equation, both sides. So by logarithmic differentiation, taking natural log of the given equation on both sides, taking natural log on both sides of equation number 1. So whenever we take natural log of y, so that will become natural log of y, and this is natural log of 2 power x. Using the property of logarithmic function, this x will become the front of log of 2. So that is natural log of y. Now differentiating with respect to x, both sides, this side as well as this side. From this side, this is actually natural log of u. So derivative of natural log of u is 1 by u, 1 by y, into further derivative of y. And from here we see that natural log of y is constant. So natural log of y will be outside of this derivative, and the left is this side is d derivative of x. Now derivative of x is 1. Natural log of 2 into 1 is natural log of 2. But we need derivative of y. So multiplying both sides by y, we will get dy dx this side, and this y will be multiplied towards that side. So that will become y into natural log of 2. But we know that y is given to us 2 power x. So replacing this y by its own value, this y is 2 power x. We see that the derivative by using the logarithmic differentiation and by using the formula are the same. These two are the same. Question number 29. First of all, we will differentiate this function with the help of the formula, and then by using logarithmic differentiation. We see here that the base of this function is pi, and we know that pi is a constant number, 3.14 and so on. So that is a constant number, not a variable. Pi power sine x, and x is in the power. So the base is constant and power is variable, so that is exponential function. And secondly, we see that this base is not e, this base is other than e. So whenever you differentiate this function with respect to x, both sides, we'll get here derivative of this exponential function is the same exponential function into natural log of the base, into derivative of the power, which is sine x, and the derivative of sine x is cos of x. So that is the derivative of pi to the power sine x by using the formula. Now whenever we use the logarithmic differentiation, so for this purpose we will take natural log on both sides of equation number 1. So taking natural log of both sides, natural log of y into natural log of pi to the power sine x, and using the property of log function, this sine x will be in this fashion, sine of x into natural log of pi. Now differentiate this function with respect to x. Whenever you differentiate this function with respect to x, so that is differentiating with respect to x. This side is derivative of log of u, so derivative of log of u is 1 by u, derivative of u, I mean y, and pi is constant, so log of pi is again constant. So writing this log of pi in front of this derivative, and we are left with derivative of sine x, and derivative of sine x is cos of x, so that is 1 by y dy dx is equal to this thing. We need this thing, so multiplying both sides by y, we'll get this equation. Y will be cancelled out from this side and will be multiplied on that side, so that is y. And the last step is we need to replace y by its own value, which is pi to the power sine x. That is the value of y. The given question, y is pi to the power sine x. So we have replaced this y by pi to the power sine x, and see that this answer and the answer obtained by the formula, both are the same. In this slide, we will be studying the derivatives of inverse trigonometric functions. We know what are trigonometric functions: sine x, cos x, tangent x, secant, cosecant, cotangent. All are these functions are called trigonometric functions. Now in this slide we will be studying here the derivatives of inverse trigonometric functions. The derivative of the inverse of sine, inverse of cos, tangent, cotangent, secant and cosecant. So this is simple form, and that is extended form. What does it mean? It means that if the angle is x only, so that is simple form, and whenever this angle is the function of x, so that will be extended form. So derivative of sine inverse x is equal to 1 divided by 1 minus angle square, this x square, 1 divided by 1 minus angle square. And whenever this is extended form, so that is the same, 1 divided by 1 minus angle square, but with the product of the derivative of the angle u. Similarly, the difference between cos inverse and sine inverse is only this negative sign. That function which starts from c contains negative sign for its derivative. Cos starts from c, so derivative of cos inverse is negative. Cotangent is negative, derivative of cotangent is negative. Similarly, derivative of cosecant inverse is negative. So that function which starts from c having derivative with negative sign. Secondly, the derivative of sine inverse and cos inverse are the same, just this negative sign is extended in the derivative of cos inverse. And similarly, the derivative of tangent inverse and cotangent inverse are same, but for cotangent inverse we'll put a negative sign in front of that fraction. Similarly, the derivatives of secant inverse and cosecant inverse are same, with the addition of negative sign of the derivative of cosecant inverse. Derivative of tan inverse is 1 by 1 plus angle square. The same rule will be followed here with the extension of the derivative of this angle again, and cotangent inverse is of course the negative of tangent inverse. Similarly, the derivative of secant inverse is 1 divided by angle, this angle x, 1 divided by angle square root of angle square minus 1, angle square root of angle square minus 1. The same will be followed for cosecant inverse with a negative sign. And extended form is in front of you. So these are the derivatives of inverse trigonometric functions. Those questions, question number 43 to 58, will be on those formulas. We need to find the derivative of y, and in question number 43 we are given a function y is equal to sine inverse 3x. So differentiating this function with respect to x, whenever we differentiate this function with respect to x, we'll get this form. And now just look at this side. This is the derivative of sine inverse u. So derivative of sine inverse u is 1 divided by square root of 1 minus u square into further derivative of this u. Now we can write 3x whole square as 9x square. You can write here 9x square, and further derivative of 3x is 3 into 1. 3 into 1 into 1 is 3, so that is the derivative of sine inverse 3x. Similarly, for question number 44, we are given a function cos inverse x plus 1 by 2. So differentiate this function with respect to x, that is derivative of cos inverse u. We know that the derivative of cos inverse is negative of the derivative of sine. So that is the negative of 1 divided by square root of 1 minus angle square into further derivative of this angle x plus 1 by 2. Now derivative of x is 1, derivative of 1 is 0, so that is 1 plus 0 by 2, and multiplying this one with this one, 1 ones are 1, and writing this 2 in front of this square root to get the derivative of cos inverse x plus 1 by 2. Question number 50 says that find the derivative of y is equal to 1 by tan inverse x. 1 by tan inverse x can be written in this fashion: tan inverse x whole inverse. Whenever we differentiate this function with respect to x, so be careful, this inverse is the whole power of tan inverse x. So that is actually power rule, extended power rule, of course. So applying the extended power rule, bringing this power in the front of this function and subtracting 1 from the power into further derivative of this base, which is tangent inverse x. Now further derivative of tangent inverse x, we can write this as minus 1, that is minus 2, and derivative of tangent inverse x from the table is 1 divided by 1 plus x square. Now we see here that the power of tan inverse is negative, so bring it down here to make it positive, and that is the negative sign which is in front of this fraction. So that is the derivative of 1 divided by tan inverse x.